Well, hello everybody. We're going to do a couple more proofs here. We're going to take it a step further. So today, as we go through these proofs, we are going to solve not for a triangle, but for one step after that. So we need to make sure that we first show the triangles congruent and then take it that one step further. So the first thing I'm going to do is write down my given statements. AB is congruent to DC, given. The given statement is angle ABC is congruent to angle DCB. Those are my given statements. I should probably mark them on my drawing, because that's supposed to be given, not given. Anyway, we'll mark them on our drawings. So angle AB and DC are given, and ABC, so this full angle right here, and that full angle right there. So let's take these triangles apart and draw them. So we have AB and this angle. So there's A, B, C. And on the other side, we have a triangle that looks like this. That is D, C, B. We gave you that one and that side. You will notice that we have a reflexive side right here of BC that is in both triangles. So BC is congruent to BC. And that is reflexive property. And you'll notice that we haven't changed anything we've been doing at this point. Step 4, well, you notice that we have the triangles congruent to one another. Triangle ABC is congruent to triangle DCB. Make sure you get them in the right order. And that is by, well, we've got a side, an angle, and a side, so that's side, angle, side. And then finally, our final step is that once we have the triangles congruent, any other parts that we have can be congruent inside of those triangles by CPCTC. So we can say that angle A is congruent to angle D by corresponding parts of congruent triangles are congruent. All right, let's try another one. Well, in this one, I already have a couple given statements here. Actually, let's clear them out. All right, so let's write our given statements. Statement 1 is AE is congruent to EC. That's given, and we'll mark it. What was it? AE and EC. Over here, we have BE is congruent to ED. That is also given. So BE and ED. So then at this point, you may notice that we have two sides again, and we're trying to prove this AB here and DC are congruent to each other, but we don't know any information about them. So the first thing we need to do is get these triangles congruent. And as I look at this, I see some angles that are congruent here at E. And so we have angle AEB is congruent to angle DEC. And our reason for that is vertical angles. So now, since these angles are congruent to one another, you'll notice I've got enough information. I've got 3 pieces of information in each triangle. So I've got enough information to prove that triangle AEB is congruent to triangle, let's see, it's got to be CED. To make that match up, I went 1 angle 2, so 1 marked angle and then 2 marks, so that's how they have to match up. And so then those triangles are congruent by side, angle, side. And now that we got the triangles congruent, we can say, oh, we've got these extra parts that we want to prove congruent. So we take it one step further and say that AB is congruent to DC. And we can say that by corresponding parts, congruent triangles are congruent. CPCTC. All right, we got one more proof to go. And in this proof, they give us some more information up here. They don't give us flat out what's happening, so we're going to have to add some things in as we go here. So let's first write down our given statements. Statement 1, y is the midpoint I'm going to abbreviate midpoint. Midpoint of xz, that was given. And then 2, we know that angle xyw is a right angle. All right, that's also a given. So let's look at what we got here. Y is the midpoint of xz, and xyw is a right angle. All right, so I'm going to start with the midpoint information here. And I know that a midpoint is the middle point of a segment. It cuts the segment into 2 equal pieces. So xy is congruent to yz, and it's not a bisector. It is a definition of midpoint, because that's what they told me. Definition of midpoint, so I now know this and that. They told me in my given that xyw is a right angle, and since that's a right angle, then we might be able to go with the fact that that the x, y, z, and makes a linear pair. So we can say that, well, let's see how we're going to say this. We are going to say that xyz, or yeah, xyw is 90 degrees. And so we can say, well, we'll just say that angle wyz is a right angle. And we can say that because we have a linear pair, and we haven't used that one yet, so this guy's a right angle. And then we can say, oh, the next thing is that wyz is congruent to xyw. All right angles are congruent. So then step 6, I'm going to have to kind of squeeze in here, this little box is in my way. Step 6 is, you notice that we have a reflexive side here, so that wy is congruent to wy. That is reflexive property. Step 7, now we have enough information to prove each triangle congruent. So we can say triangle xyw is congruent to, and see I went across the single to the right angle across the double, so I got to use zyw, and that is by, again, side, angle, side. Seems to be all of them that way. And now that we have that, we're going to go one step further and prove that xwy, so this angle right here, is congruent to that angle, is what we're trying to prove, zwy. And since we got the triangles congruent, we can pick any pieces we want in there. And so we can finally say that angle xwy is congruent to zwy by CPCTC. Corresponding parts of congruent triangles are congruent. So that concludes all of our proofs for the day. Once you complete this, you can start working on your homework. Thank you.